Astronomers have just captured new high-resolution images of 3I, Atlas, an interstellar visitor unlike anything we've seen, and what they're seeing has left even seasoned scientists speechless. The object is accelerating without any visible cause. No dust, no gas, no tail, just motion that defies gravity itself. Something is pushing a 6-kilometer wide body tens of thousands of kilometers off its predicted course, yet no telescope can see what's doing the pushing. In 2025, Hubble recorded a series of sharp, clean images showing Atlas as a compact, star-like point with no visible coma or debris. Even as it neared the Sun, the object remained unchanged, smooth, silent, and dark. Normally, the heat of perihelion triggers violent outbursts of vapor and dust, forming the brilliant halos we associate with comets. But Atlas stayed eerily calm. Every instrument, Hubble, Webb, and ground-based telescopes, saw the same thing: nothing. Then came the numbers. In early November, astronomers noticed the object had drifted 4 arcseconds off its predicted orbit, about 80,000 kilometers of unaccounted movement. That shift means Atlas is under a measurable, persistent acceleration of roughly 0.02 millimeters per second squared. For a 6-kilometer object weighing billions of tons, the force required is enormous, comparable to the thrust of a continuous engine. Yet, there's no plume, no glow, no energy signature. To explain such motion naturally, the object would have to vent over 5 billion tons of material in weeks, an event bright enough to outshine most comets in the sky. But telescopes scanning every wavelength see none of it. No gas lines, no dust trails, no ultraviolet glow. The sky remains silent, and that silence is now one of the loudest mysteries in modern astronomy. Atlas reached its closest point to the Sun on October 30, 2025, and will pass near Earth on December 19 at a safe distance of 167 million miles. During this period, a global campaign is underway. The James Webb Space Telescope will hunt for the faintest traces of vapor. Hubble will monitor for any visual changes. Ground-based observatories, from the VLT to Subaru and Gemini, will run constant photometry and spectroscopy. If there's even a hint of gas or dust, it will be caught. If not, the case for natural physics collapses. But the light data complicates things further. As Atlas approached the Sun, its brightness increased far faster than expected, following an extreme r to the power of 7 to the power of 5 curve, 10 times steeper than any known comet. At the same time, its color shifted to blue, defying the warm hues of dust-scattering sunlight. Blue tones usually indicate gas emissions, yet no gas was detected. The pattern repeats across instruments, ruling out error. The change is real, but the cause remains unknown. 9 key anomalies now define 3I, Atlas. It entered the solar system along a near-perfect ecliptic alignment, rare for interstellar objects. It displayed a jet pointed toward the Sun instead of away. Its mass, speed, and orbital clustering with Mars, Venus, and Jupiter are statistically improbable. It contains far more nickel than iron, just 4% water by mass, and its polarization signature doesn't match any known dust. Even its arrival direction aligns eerily close to the 1977 "wow" signal. None of this fits comfortably inside standard cometary science. Harvard astrophysicist Avi Loeb has become one of the most outspoken voices on the mystery. His message is simple: stop forcing the data to fit old models. If something accelerates without visible outgassing, we must confront what the evidence implies. Loeb's approach is methodical: treat every anomaly as a data point, not a coincidence. If the object produces a coma, fine, the natural model holds. But if it doesn't, the physics must change. By January 2026, the verdict will be clear. If Webb or Hubble detect bright gas emission lines or a wide coma exceeding 10,000 kilometers, Atlas will be classified as a strange but natural comet. If the sky remains dark, if there's no dust, no gas, no glow, then we'll be forced to accept that something else is at work. Whatever the outcome, the next few months will mark one of the most decisive moments in modern astronomy. Atlas has handed us a test of how far we're willing to follow the evidence. Nature or technology, comet or construct, something out there is moving against the laws we thought were unbreakable. The question now isn't what 3I Atlas is. It's whether we're ready to believe what the data is already telling us.